All right, are we live? We're live. Great. Okay, so tweet. Okay. All right. Okay. Turn the brightness up. Oh, so much easier to see. Okay. Um, okay, so we found out we didn't need primitive. We just spec'd out this inner class. Okay. What happens if we save links primitive array false subspec false? Yet the primitive is array. Because it's data flow. Okay, perfect. So we only want a subspec. So we say the primitive is an array, but we only subspec true if, okay, we only subspec true if we can instantiate it without the security implications or security issues. All right, so failed to auto create definition invalid name error. Okay, so okay, post init 238. This isn't that, is it? 388. Let me just, all right, so class call name definition, create definition. So so if this isn't a definition, let's see, is it picking up audio? Yeah, okay. So if this isn't a definition, um, okay, I is data flow. Um, definition container is probably an input here. So self inputs, okay. Hmm. Okay. Definition container name. Okay, so this would be to do, or let's see. So this is basically anything of this type, or anything with definitions. Definition container, enter, definition container, definition self, definition container name. All right, so then definition container, F, uh, so how do we do it in op? New type to definition, new type feed face, name feed type, feed face links, create definition, name super type. Oh, wait, this thing does call that shit. Okay. Okay, where did we introduce the bug? 380. Okay. Definition container, read, get, grep, create definition. Okay, let's grab some context. Okay, so let's look for our other examples that are working. So create definition, name. What is create definition here? Name. Okay, so create definition, name list, kwargs name. Okay, so this is what it's doing in input. So this is operation. So kwargs name. So this would be um, name list. Actually, I think that code just goes in here. name list. Param default get Iter. Definition qual name. So this is just converting types to definitions. So this has no knowledge of defaults. Okay. Here we are, it's input name equals create definition. So this is name list. So this is so we effectively have that. Let's see what happens. KWX is not defined. Self.name. Inputs name. It's not name. It's I. And it's definition container name. And stir I in the case that I is an integer when we're iterating over the conditions. However, if we're iterating over the conditions, I don't think we add that if we're iterating over the conditions. Okay, so we'll just say stir I plus a list plus this expression, which is a list of stir I, which is a list of I if definition container name if is, or let's see, I if is, if not is instance. Yeah. So let's do stir I if not is, if instance that, else we'll just do whatever. Conditionals, just any definition that exists already. So the conditions, yeah, conditions already exist, right? Let's see. Or no, let's see. Okay, so it just is a condition. It doesn't have any specific name, does it? I think that should at least get us going. Okay, so where's that in print is there? Well, definition, value, create definition. What is this? This is an input. Okay, so the input, definition, create definition. If an input is passed, something to create a definition from, it should just say new type. New typed definition. Because it doesn't know what to do with. All right, let's see. What if it's something? Name. Name. Yeah, I think we can set name to nothing here. 380 or 839, 839. Okay, unhashable type list. Okay, so let's do breakpoint. Print. Okay. Self.definitions. Okay, so definitions equals list. Set chain definitions value. Definitions. Item definition. Item and self seed. Seed. Okay, nothing in seed. So what are you mad about? Okay, unhashable type list. Okay, so what do we got? What do we got? So definitions. Definitions equals list. Definitions dot values. Unhashable type list. Set. So something from here. It didn't like. Okay. Okay. So data flow to apply as overlay. These are showing up multiple times. Okay. Export dict is here, so we can use that. Let's say export dict. Okay. Print import. Print. All right, let's check it out. Okay, what do we got? So unhashable type list. Oh, it doesn't like the links. Okay. Let's see. It doesn't like the links. So let's go links. Where are you at? List tuple. Tuple. Links. Okay, so this needs to be a set. And this needs to be a set over here as well. All right, let's try this again. Unhashable type dict. Shit. Okay. Okay. how are we going to deal with this? Okay. So we should serialize to the IDs, the definition. Okay. Hash will type dict. Links. Well, it only needs the first link, right? So we shouldn't go all the way down. Link dot UID for link and exported links. Classroom dict linked. Okay. So when we load linked flows, when we load linked flows, okay, we can fix up definition references. However, that doesn't help us with from dict. Unhashable type. These are going to be very verbose right now. Links. Okay, links and KWIs. What is this definition? Okay, so all right. Unhashable type dict. All right, let's see what's up here. All right. All right, so we're taking a look at the data. We're going to preprint the data. Name module primitive object. Okay, so and it doesn't like the dict in the set. And before, it was just a bunch of flat stuff. So name module primitive object. Module primitive object. So I don't like doing it without keys here. Let's see. Name module primitive object. Hmm. There's a hack. Unhashable type set. Then you're a tuple too then. Congratulations. That's what happens to uncooperative data types. They become a tuple. Okay. Okay, you're all a tuple now. Congratulations. Um, you're a hashable data type. From dict. Okay, so if is instance like dict we do. So we do. There we go. Okay. That looks terrible. Um, but it'll do. So we just gotta get it. We gotta get a time check. Ugh. Okay, not good. Where are we? Fuck. Okay, we're back to this. Update definition. Okay, let's just go there. 857, 857. So, unhashable type list. Where's the list in the above object? Test. Length. It is a list. Well, each one of those is what the line fuck. Self definitions values. Yeah, that's name. Name, data flow, name, data flow. Okay. So this is what? Update definitions. So we are attempting to do, we're attempting to deduplicate. We're grabbing all the definitions and we're deduplicating. And so we say set or grab all definitions from operation and deduplicate. So unhashable type list. Test. Unhashable type list. Where is there a list here? I only see a list here. This is the only paren I see, or the only bracket I see. The rest are parens for tuples and a set, but unhashable type list. Update definitions. E57. Okay, so we're going for fastest path to get the system context running. And why did we have to do the primitive changes? Because we're playing with making. We also want to do the syntax changes as well, which means we need, okay. Okay. Error tools change self-definition values. Okay. Self.seed. Let's take out things from this thing slowly and see if it blows up. Okay. Wasn't either of those. Okay, so it's something in the operation inputs. Outputs values. So now we can target that operation outputs. What operations we're doing here, the basic overlay, the default overlay, I should say. So it's something within the inputs. It doesn't like a list. Okay, so Update definitions. Definition from dict. Okay, so let's go hunt these down. Okay. So an input. Okay. So the trick is that with the links, we really would like to understand the parent context being the data flow from dict. Maybe to call from dict, you need to pass a context. Yeah. To call from dict, you need to pass a context. No. Yeah, that could be fair. That could be fair. So effectively, okay, so if you wish to instantiate a trick is how do you bridge the sync and the async? If you wish to instantiate a definition in a synchronous environment, you need to have the links already resolved. If you wish to execute a definition deserialization in an asynchronous environment, then you don't have to have the links resolved already, right? You can lazily resolve them. Um, so okay, from dict. Where's config from dict? Hmm. So let's go check out config as dict, config from dict. Okay, with config. Base configurable. So here we do a trick. Um, we say if the basically we're deserializing a data class in this function, and if we detect that the data class or that the dictionary which we are deserializing the data class for is of has this plugin config syntax, um, then we're going to treat the plugin as a base configurable. That's the convert value. So load that basically ends up being an entry point dot load for the the value, being the plugin, and then basically we pass we pass all the config values as the config of the plugin, and we instantiate that plugin. Um, it's not clean, right? So not clean. Should we copy it? So what I'm thinking is this could be a nice little place for us to do some like introduce this temporary area for this code change, right? So we're going to do a code change, right? And we know that we're going to do a code change. Um, is this still working? YouTube. The YouTube is still working. Can you see me? All right, yeah, okay, great. Um, so so we're going to do a code change, right? Our code change is we're adding these links to the what's it called? The definition. Um, we would like, when deserializing, to be able to resolve links similarly to the data flow, right? Now we can add a context structure, or we can effectively say, if you attempt to deserialize a dictionary which with different keys to the ones that you're used to, right, then treat some of those keys as your lookup table for your other link UIDs, right, the unique identifiers. So that seems like it would work for our use case right now. Um, and I think we might just go with that. So we might just steal that trick from ourselves. So that could be a fun trick. Okay. All right. So 'Alright. Okay, so unhashable type list types 857 again. Okay, so this is the serialization. Show me the deserialization. Or no, this is update by origin. So this is just mad. This is just mad. If we were to, what's the diff on this? I just did that apparently. Okay. Okay, create definition stuff. Okay. Oh, there it is. See there it is. Doesn't matter what you do if I'm explicitly setting, doesn't matter what we did other places if we explicitly set the um, type to be a list there. So we'll just change these. Glad I caught that. Okay. Once again, this is hacks, hacks, hacks. But I mean, this is, it's like, okay. Progress? Question mark. Um, get overlay data flow merge. Progress question mark. 167. 167. Okay. From dict on data flow requires another parameter. That really surprises me. Did we throw that in somewhere? From dict. Did I save that context thing? I don't remember that. What happened to that? Let's see. Let's see. Where's data flow from dict? All right, okay, here we are. Data flow from dict takes one positional argument, but two were given. So back here, two were given. Okay, so it's a class method. It should take this thing that we're merging. So 167, we say? Are we sure about that? 167 in overlay PY? Takes one positional argument, but two were given. Did I redefine data flow somewhere? Okay. Okay, data flow, test data flow. Class data flow. Holy shit, can we say data flow one more time? Oh my god, okay. Primitive object, is it this? No, it's not this. Def from dict. Oh, KW args. Oh, so we have to do an expansion. So we're just missing the star star. Right, so if we star star, then it's gonna splat and it's gonna merge. It's not gonna merge. It's gonna take the merge flow and fuck. Okay. Unhashable type set. Unhashable type set. Oh, that's right. We have to tuple it. Okay, where'd it go? Where'd it go? Where's this? Okay, 327, 327. Okay, so from dict link tuple else link think for link. This looks like it's making, okay, that's a set. That's a set we want to tuple. Tuple. I think the tuple will just take the generator. I can never remember. I just sort of do it. Sometimes it works, sometimes it doesn't. Let's see what happens. Name at config is not defined. All right. Okay. We're farther down in the file. Wow. We haven't moved in this file in days. Okay. That's fantastic. Ooh, that stressed me out. Okay. I hope everything's okay. We just did a lot of weird stuff. Okay. Let's try to save some of that before we get more confused here about what just happened. Okay, so what happened here? Is this related? No. Is this related? No. Is this related? No. Is this related? Yes. Is this related? Yes. Yes? Question mark? Yes. Yes. Is this related? E. We want to edit this one because we don't want to add this right now, but we do want to add that. We do want to add this links, links, links. Fuck, these are two unrelated things. Ah, fuck, okay. Is links related to the definition stuff? No, links is not related to the definition stuff. Links is somewhat related to the definition stuff. Staged. Let's try it. Oh, shit. Let's try this again. So let's do the create definition stuff first. Okay. Okay. That sets links though. So let's do that for now. Fuck. I guess. This is links. This is links. This is links. This is definitions, fixing up definition stuff. This is fixing up definition stuff. This is fixing up definition stuff and links. That looks like we shouldn't, should we commit this here? Yeah, this is just a formatting change. Let's edit it. So let's not add that. Let's not add that. Let's not add that. Right. So don't add the bits that were just, so this is just a formatting change. Right quit. Okay, this is not something that we want to add to Git. This is not something that's related to definitions, not related to definitions. Remember, we're doing definitions right now, not related to definitions entirely. Too related to overlays, too related to command structures. No, no. System context stuff. That is related to the command stuff, overlay stuff. This is Alice. There's more Alice. Don't need that, don't need that, don't need that right now. Okay. Okay, so what do we end up with? Okay, so this is some more fix up on our create definition stuff. So let's look at the log. What did we say? Move create definition. So let's just do git commit sm. Okay, create definition. Uh, uh, so what is this? Git diff staged. So what are we doing here? So we are fixing up param annotations that are classes and ensuring the correct name gets used. Okay, so fix up naming and param annotations, which are classes slash objects. Okay. Now let's add the link stuff. Once again, now I think we're out of the link land. Okay, yeah, I think we're out of link land here. I'm getting deja vu. I'm getting deja vu to last time. I think I said something about the links and the peers. Okay. df types, definition, links, hacky, initial support for links, produces verbose duplicate information instead of referencing uh, 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 other definitions within links via ID, considered patching, from dict. I like that idea actually. From or definition. To support config dot from dict style is config dict check to determine if we should deserialize and reference links found within specialize config or dict representation. Deserialize is not the right word. That implies that there's a format involved. This is really just a data structure. Reference links found within specialized dict representation. Check to determine if we should deserialize and reference links found with a specialized dict representation to facilitate synchronous reconstruction of really of a reconstruction of links without duplication of definition definition data similar to data flow dot linked. Okay, so I actually like this more and more the more I think about it. So recording, I think I think it's interesting. So what I think that we should seriously consider doing more messing around with that. So that concept. What time is it? 58. So what? Let's say about uh, what is it? Question mark. Uh, T equals 50. So um, so 50 times 60. Okay, so 3,000. Is that right? 3,000 seconds in? That doesn't seem right. Times 60 times 60. 60 seconds times 50 minutes. It's 3,000 seconds. Sure. Okay. Push that up. Okay. All right. Name config is not defined. What the hell are we doing over here? System context dot system context. Okay, so let's go clean up overlay apparently. Time check. 3:58. Fantastic. $179. Add config. Diff mount installed overlays config. I don't think we need, do we need this? Diff mount installed overlays config. No, we don't need that. We just need this diff mount installed overlays, which is our first config class. Yay! Default factory for subclass. Default factory for subclass. Let's just say subclass. What happens if we say subclass? Well, if we say subclass, get grep dash C or dash B or dash A 10 def subclass def backslash space subclass. Okay, so a 40 or 60. Okay, so this is in with dfml util CLI command, but this really could be in any base data flow facilitator object. So let's go ahead and actually throw this into the base data flow facilitator object, which I believe command derives from. So where is that? So that is, I thought we had a window open for that. Util entry point, maybe it's down here. Maybe we should not do this in a different context. Okay, let's look. Let's see if it's open somewhere. There it is. How do I attach to a running process in a different terminal? That'd be sweet. Say fx grab dash c4. Okay, so it's over with index HTML. Where's index HTML open? I don't see that anywhere. Is there a way to blow up the panes? I thought there was a way to blow up the panes. Let's see. Okay, so where's that? Where's that? Where's that? Util entry point, dump discussion, nodemon, system context. Am I looking right at it? There it is. Where the hell is this? Oh, okay, so let's go grab def subclass. Let's throw this in base. Base data flow facilitator object, and we can throw it base data flow facilitator object context. So if we throw it on, no, let's not throw it on there. So let's throw it on. Honestly, should we just throw it on? So should we just throw it on here? Quite honestly, like, does it really even matter? Config. Let's just throw it on here. Why not? What if you wanted to? What if you wanted to do it this way? Maybe you do. Maybe we provide too many options. Let's see. Let's see. So, okay, so diagram, that should get it. This example should still be the same. We just need to make sure replace config is around here. There it is. Okay. Yeah, because this should get this method through there, through there, through there, through here. Is command is just a base object though. Okay, so that's unfortunate. So what about would you like to be a base data flow facilitator object? I think you would. Okay. Oh, it's not even used. Let's see what happens. It might blow up. System context is not defined. System context is not defined. Well, we got somewhere, sort of. So where are we here? This is system context here. No, that's dump discussion. System context isn't open. Okay, so let's import from base system context, import, so from system context dot system context, import system context. Explicit is better than implicit. Okay, so base data, look at, there it is, and there it is. Here we are. Okay, what is this? This is not, once again, this is dump discussion. DFML, system context, system context. Okay, system context. Here we are. The system context is the upstream, the overlay, and the orchestrator. We can use it to represent the past, present, and the future. And our synchronization between states in time. So via the application of the overlays to the upstream. So base data flow facilitator object context is not defined. There it is. Let's define it. Let's pull it on in. Base, replace config. And I assume you'll be wanting the version without context as well. Okay, let's run formatter on that. Okay, add config. Let's make sure we import config. We'll probably want field too. Do we want field? Okay, yeah, we do want field because we should go describe these things. All right, so we should say field. The system context, which this one is a derivative, or which this one was created due to upstream the overlay in the orchestrator. Okay, now I'm beginning to think. I just realized, well, your upstream, it's fine because within your upstream, you could have already combined several things. The point is that, yeah, okay, because the overlay, okay, it's created as a result of the system context, which created this system context, or which this system context is to be derived from or duplicated exactly. Or duplicated exactly, aka rerun or something. Okay. All right, the overlay we will apply with any overlays to apply within it to merge within it. C default overlay usage docs. And the system context, whose default flow will be used for orchestration, used to yield an orchestrator, which will be used to produce an orchestrator, which will be used to execute this system context. This system context, including application of overlays. Okay, so when we execute the system context to apply overlays, how should we, let's see, how should we allow for, okay, so we want to execute the system context using the orchestrator provided via execution of the default method of the system context provided for the orchestrator. We're going to do a quick little hack here where we're just basically going to say, hey, if you gave me an orchestrator right out the bat, I'm not even going to bother executing the system context. I'm just going to use the orchestrator that you gave me. Um, I think that's what we're going to end up doing here. I'm not exactly sure yet, but time check. So yeah, that's probably what we're going to end up doing. So system context is default. Okay. Okay. So when we execute it, so if we wanted to execute with a different orchestrator when we actually go to run the data flow itself, we could yield, or we could return from the overlay application instead of returning the flow or the meshed system context. Let's see. So we take the upstream, when we combine it with and we combine all the overlays. We run the overlay, which combines all the loaded overlays, which then runs the upstream, uh, which then runs the upstream, which then passes. Okay, then runs. So we merge all the overlays together. We load all the overlays. We merge them together. We take the input flow, we apply the overlays, we run the overlays on the flow, we pass them the flow, they can do whatever they want with it, then we remerge the flow back together with all the modifications that each overlay made. This is the default, at which point we hand to the orchestrator for execution. If we hand the orchestrator for execution a data flow, which actually just, or a system context, emerge system context, which is really just a system context using another orchestrator. We determined we wanted to use a different orchestrator, right? So maybe the default system, so maybe we have, for example, we could, for example, install a default overlay, which basically will run on any system context which is loaded on a system, and say, hey, if the resource usage looks like this system doesn't have enough, maybe this system that you happen to load on is, we know we have a lot of IoT devices, and so when we when we do an edge deployment, and we are going to ensure that uh, the spins of our software getting deployed to these IoT devices are going to have this overlay pre-installed, which will run every single time, right, a new system context is executed. And it might say, hey, for the orchestrator, why don't you actually, before you return the system, basically, okay, so basically the overlay, this installed overlay would it would make sure that the data flow that gets returned is a is a uses an orchestrator that has an operation implementation network, which has been configured using whatever attestation flows that happened within the overlay to connect to a edge server, right? So deployment becomes trivial, basically. Okay. So let's see. Where are we? What are we doing? Where are we? What are we doing? Load default deployment environment is not defined. Okay. What did we just do? Okay. Okay. Shit. Okay. 414 or 214. Load default deployment environment is not defined. Okay, set NU. Load default deployment environment. Okay, so load default deployment environment. What happened to that underscore class that we had? I think it got lost in overlay, didn't it? Um, where are you? Where are you? Where are you? Load default. Okay. Okay. Okay, looks like overlay says load default. So that didn't get changed. So we'll change that in overlay. We did change it here in the system context. Okay, so we'll grab these guys. We'll create our little, what is this thing called? It's the data classes library will tell you. I'm not sure what it is. Sentinel? Sentinel? Sentinel doesn't sound right. It sounds right, but it doesn't sound right. All right, okay, shit. Okay. Okay. Ha. Um, okay. Okay. Union not defined. right? So Alice sees union not defined, boom, she imports typing for us, right? So we're going to get this cross-language situation down. Okay, Alice is not defined. Yes, we're working on it. Working on that one. That's the point. Okay. Ooh, some smells good. Let's see. Alice is not defined. Alice is not defined. Alice is not defined. All right, I'm happy with that right now. Not because Alice is not defined, but because that's where we should be at. So open architecture is not defined. Also working on that one. Thank you very much, Stack Trace. It's a process. Come on, come on, come on. Okay, so, got not blow into the microphone. Come on, come on, come on, come on, come on. Load default deployment environment. All right, what do we need to do? So by, okay, shit, okay, I'm not going to talk. Open architecture is not defined. Okay, so where's that? Hey, I want to commit this. System context, initial initial scratch code, or initial, let's see, plugin type. All right, let's push that shit up. Okay. Subclass. Oh yeah, that's right. Let's go ahead and move. Okay, so this just really. Okay, let's just do that. Always staged. Always inspect before you commit. Always do status and staged. Okay, I didn't do status, but always do it. Base. Okay, so update type definition space replace config replace config replace config. What did we do here? Okay, so what is this patch? All right, so we base replace. So in the base.py file within the main package within the replace config function. So base colon replace config colon. We are going to change input and return signature uh, signature parameter annotations from base config to any. Push that. All right. All right. Okay. DFML util CLI command. All right, so let's move this over here. Okay, so let's also -k subclass. Let's go test that. Okay, let's go remove this from overlay. Upstream, system context subclass, system context. Okay, so let's go ahead and say that we can say, let's just allow for this right now. So let's allow for setting the upstream as a data flow and the orchestrator as an orchestrator. Maybe we'll just say memory orchestrator and then it can instantiate it on its own if it sees it. All right, so if you pass it a class, ow, ooh, if you pass it a class, figure it out. Yeah, instantiate the class when you needed it. Okay, this is probably going to trip me up later. I'm going to get really confused about why we don't have an instantiated memory orchestrator. If anybody is watching this, remind me when I start getting confused for hours on end, because this one usually gets me. So maybe we should put to do Alice. This will need to make sure we have. Is this completely? terribly ergonomic. My hand is like weird. Um, I'll need to make sure we have code to instantiate an instance of a class. Yeah, I think this is not right. There's something wrong here. Yeah, maybe I should fix this. Probably. Okay. We'll need to make sure we have code to instantiate an instance of the class. If I can't type, then I'm screwed. So let's see. We'll need to make sure we have code to instantiate an instance of a class if only a class is given and not an instance. It's not a big problem, but we need to make sure we do it. So let's go back into, let's see, where are we at? System context, open architecture, subclass, got an unexpected keyword argument upstream. Time check. All right. Oh, wrong file. Okay. All right. Let's comply with the requests of this thing for now. I'm not in love with this API here for subclassing. I'll tell you that. Whew, boy, am I not. Um, but we need to we need something. Okay. You know what? Here we go. Let's just still leave that to do though. Alice, can you just do that for us, please? Thanks. Ooh, that will be great. Default factory. That is the goal. Um, merge is not defined. DFML, DF base. Merge, where's base? Okay. Uh, merge, merge. Make config, replace config, merge. Util data, merge. Import it. What do we got? Cannot import blank from blank. Cannot import DFML overlays installed. Git grep DFML overlays installed. Make sure we copy paste. I've spelled thing wrong way too many times. Okay, overlay equals DFML overlays installed. Okay, I think this is a case of misspelling. Yep, it's a case of misspelling. Thank God I copy pasted. Okay, who's wrong? Okay, oh, wow, I would have never gotten that one. Okay, DFML overlays installed. Yeah, I think it should be DFML overlays installed rather than installed overlays, because that sort of is more clear, I think. Um, okay, that looks better. Unexpected indent. Unexpected indent. Okay. Unexpected indent. 359. Okay, you see why I want for help switching back and forth between windows now. Let's see. I want to just jump right to that focus if it pops up. But where is it right now? Where are you? Where are you? Here? This looks familiar. Base? No. Here? Yes, here. Okay. 359. We have an unexpected indent. 359. Okay. Yes, so we do. Okay, where are we? Okay, this is good. Are you okay? Did you roll off? No. Did you get too close to the edge? I love you. Are you okay? No. Yeah. What about this? There you go. All right, sweet. Okay. Um, where are we? Okay. Oh, fantastic. Okay. Um, this looks like, okay, this is a bunch of random stuff that we were just messing with. So let's just pull this out of here. Okay, I think we put most of this in system context anyways. And why were we even doing this? Oh, because we wanted to do system context.run directly. And so we were going to do await. Okay, where are we? Run CLI command. I think we were just going to do system context. Okay, yeah, so let's do, this was our initial attempt, right? So let's go. Upstream is the data flow, and the orchestrator is memory orchestrator. Okay, great. Um, we have no overlay in this case. Okay, damn it. Okay. Yeah, overlays none. Okay, we had an overlay that wasn't defined. Okay, there it is. Subclass. Okay. Overlay. Default lambda. Okay, so default factory load. Okay. Unexpected indent. Where did it go? Where did it go? Okay, here. Where's Alice? Alice, where are you? There she is. Okay. Await self dot system context dot run. Okay, so I think this will go in the system context code, which is not open. Okay, great. Okay, so we're going to paste this in here. Right. Okay. System context would be this thing, and this is going to, so basically, if this system context package is installed, let's go make a package. So this is system context, system context. Okay, so now we need to create a plugin. So dfml, so cd. We're going to be able to create plugins on the fly using this. So that'll be fun. Basically, you can take Python files and turn them into whole packages because you have your tree. You have your dependency tree defined dynamically. Okay, so where are we? What are we doing? Okay, so let's go to Wonderland. Let's see, where should we put Wonderland? Okay, so entities, let's just do system context, mkdir system context. Maybe we'll just say context. CD context. tfml.models. tfml.context. Yeah, okay. Blank. Okay. So we'll call this one system context tfml context Wonderland. Okay. Or no, let's just do dfml context all. dfml context installed. Okay. Fuck. Okay. Cannot import name run from high level. Okay. Don't worry about it because run from high level. Where is this? This is base. This doesn't matter. So get grep. Where are we? Where's that file? I don't think it's open. No, it's not open. Bubbles. Let's see. Stuck, I think. Let's see. So we need to go to diffma. Where are we? Okay, not there, not there. Oh, there it is. Control B Q, and then Control B Q, Control B4, or wait, Control BQ4, Control BQ5, Control BQ4, switches the panes. And Control BQ shows you which one you're on. Okay, so arg5, what was that? I want to know what that does. Run. Okay, looks like somebody tried to import that. I don't know who that was, just kidding. All right, so let's get rid of that. Okay, do run. Okay, so here's the usage of the function, but we're going to say, basically, return await system context, and we should say, extra config, sanitize args. Equals extra config. Okay, let's say extra config. Yeah, let's do by key value right now. Args command. All right, let's call this. All right, so on the other side of this, we should do basically what we had there, right? So run the system context for, run the top level system context for the CLI. Okay, so config time check. 38. Not good. Okay. Where are we? What do we need to get done? 4. 38. So in the past 20 minutes, how much progress have we made? Okay. Can we get to overlays? We can do it. We can do it. We can do it. We can get to overlays by 4. We can get to overlays by 4. Come on, come on, come on. Okay. Okay, system context, extra config, args command. So this will be, okay. So let's go grab this stuff. Okay. Okay. Okay, so deployment. Okay. Call system context. Call self context. Okay. So deployment system context dot deployment environment, load default deployment environment produces a callable. So we want a callable for the CLI. So let's go ahead and jump back over. Let's actually do this. Let's get out of here. Let's clean up a little bit. What is this dump discussion? Yeah, that's what we're doing here. We're trying to back it up. We're trying to back it up and then implement at the same time. Basically, we got into backing up the thread and we started doing the work while we were backing up the thread. Um, so in order to back up the thread. So we have one backup, but we don't have synchronized time states, basically snapshots in time. And so, okay. Maybe I should take a little break here. I'll be right back. No. Okay. Apply overlays installed. We got to get rid of some of this stuff. Okay, cache download wrapper. That's going to be important here right now. Installed overlays. Okay, but where are we? That stuff we can leave there. Okay, so maybe this is just, we put this here. We say what? Oh, yes, thank you, Hashim. Oh my God, I can't believe I had done that. Hashim very nicely fixed that problem that I created there with that ridiculous cache download wrapper. C blank for cache download wrapper code. Okay. Create a new function. So let's just return an async def function first. Or wait, yeah, let's try, here we go. So this can be our basics, right? Yield CTX results, right? So this is our basics, right? All right, so to do fix up function signature inspect function signature fix up inspect function signature on yielded func including return type annotation, right? So let's help the type checker out because we will be checking the type and creating subsequent operations probably out of system context themselves, right? So basically what we can do is we can do system context deployment. It can return a typed function from which we can actually include in another system context, and we can blow up the AST trees of these things and basically allow for hot swapping any function for any level of instrumentation at any locality wherever we want across languages. And that also allows us for data collection as well, right? Because that's what I mean. It's basically like we're fuzzing. So we're fuzzing for more optimal configurations. So rather than just integrity, right? We're fuzzing for the overall architecture and different configurations thereof. So to find more optimal configurations, including maybe things that have better security properties. So let us see here. It looks like we need to analyze the operations without auto start. So we can look at input flow. So this is our allow list. So we don't have the allow list yet. So let's put a to do or no. Okay. So um, uh, okay. So we don't have a allow list for data flow. Inputs from each origin specify data flow. Data flow should specify which origins, or let's see. Okay, so allow list for data flow inputs from each origin. Run top level system context for CLI commands. allow list for data flow for inputs for each origin, including what seat or origin values are for acceptable inputs. For now, we consult data flow dot flow. This is potentially correct already, but let's just double check. Okay, so where do we do that? How do we do that? Let me make sure Ruffles is okay. Okay. VS split, df of mal, df, df types. Let's go look at, now we're in, so we're gonna blow this up. So now we're double pane vimmed. We can copy paste back and forth. So we need to go to class data flow. We need to look for flow. Okay. Is flow itself a structure? I believe it is. Or what is flow? Flow colon flow colon is dict input flow, stir input flow. So it's a mapping. It's a mapping of operation instance names to input flow objects, which are inputs, outputs, and conditionals. Let's see, representing, yes, no, inputs and conditionals, representing the alternate definitions that they may come from. Okay, or alternate origins. So, yeah, get alternate definitions. Okay, so we need to look through flow to understand. Let's go get rid of this stuff. Okay, let's look through flow. Okay, if is instance. Let's just call this deployment async iter func. Okay. So let's say class system context. Deployment. Okay. I don't love this because it's not very dynamic. I wonder if we can enumerate all the types. I'm worried that there's more types that we can't enumerate or something. Okay. Okay. operates on data flows. I don't know what to do with this right now, so we're just going to do this. Right, so we'll just do this for now, right? So this is all this is all we can figure out how to do right now. So we're just going to do our async iter function return for everything. Um, okay, so deployment environment. Okay, so deployment environment, aka method for data flow as class, aka output flows to be overlaid, uh, or no, aka operations to run. Okay, so how do we know? How do we know what to add here, right? So func, let's only take kwargs for now, right? And then let's basically just go through here and map kwargs, key. So let's see. So for key comma value in kwargs.items, we're going to do, the value, and then we're going to look up the key is the operation. So if deployment environment, equals uh, the default, whatever the hell it is, right? This thing that says load the default. Um, then deployment environment equals default environment is load default deployment environment. Async def function. If deployment environment is load default deployment environment equals blank. Or wait, no. Okay. How do you determine the default execution of it? You basically just look for, okay, so if deployment environment is load default employment environment, so if we are to load the default deployment environment, that means we are not running any specific operation. We are going to, okay, I'm not even sure that to-do list is a little funky. Okay, so, oof, all right, here we go, time check. Ooh, 55, okay. If we're to load default deployment environment, that means we're not running any specific operation. We're going to analyze the, uh, analyze the default flow, or analyze the, yeah, okay, so analyze the, analyze dataflow.flow. Let's see, else. elif deployment environment in class in self.upstream dot so basically we're sure upstream's a data flow right now. Deployment data flow async iter func. Okay, deployment environment. Da, 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 da. Okay. Deployment data flow async iter func. Okay. So if deployment environment in self.upstream.operations. Okay. Let's actually take this out here, produce a static method so that it takes a data flow, deployment environment, data flow, async get a func. Okay, this will do return this. Okay. Okay, self upstream. Okay. But we don't really know. Deployment async getter func. Oh, we have a problem. We don't really know what its default deployment environment is until we've run the overlay. So shit. We don't know what its default deployment environment is until we've run the overlay. Okay. Okay. Okay, so note. This assumes, so we need to remember this thing. So basically, this assumes this assumes the upstream. We are in a system context which has only an upstream, and we have already derived the upstream from application of an overlay. We cannot know to do Alice, probably because this is something we'll need to do it. We cannot know the interface for a data flow unless, or interfaces, deployment environments available for data flow unless we, okay, so, oh, how were we going to get around this? Yeah, so if you execute the default, basically you can allow for executing the default and then hooking. Um, uh, okay, so we know nothing unless we execute, we apply overlays. We can execute an incorrect default and then hook via overlays to take control. Um, uh, or we could, yeah, or something else. Okay, so self-upstream, okay. Oh, and then the deployment environment, maintain that. Okay. LF. Okay. So we know that we're going to have some structure, which defines the input definitions. The input definitions, uh, if they come from, if the input definitions come from the default deployment environment, then they will be um, basically the input definitions of the flow as a whole, which come from the origin. So to do define which origin our inputs are coming from. Okay. Shit. Okay. So when we do this deployment environment, we should say deployment environment. Okay, let's say origin, right? So uh, where are these going to come from, right? So equals seed by default. Okay, everywhere that says seed will eventually need to be changed. Uh, so input definitions. Let's make sure we add origin equals origin. Okay, add rest of sanitized data as inputs in case flow wants them. Add rest of sanitized data as inputs. Okay, I think that was from an old. Okay. Input value to the flow. Okay. Self dot. Okay. Async with. Okay, so create the orchestrator context and run the target. Okay. And add inputs as needed. Okay. All right, so input definitions, key, origin, key, value, KWX, items, overlay, overlay. Okay, no overlay. Oh, yes, we do. We overlay. We say self.overlay. Okay, so maybe this shouldn't be a static method then. Yeah, no, let's get rid of that static method. Okay. Uh, yeah, self upstream. Let's require named parameters on that star. Let's require named parameters on everything that takes a deployment environment. Okay, so upstream operations deployment environment. All right, so if we choose a specific deployment environment here, we're basically going to choose a specific operation. And when we choose that specific operation, we're going to, how are we going to do that? So we're going to say, we should probably put a conditional on it. So we should probably apply an overlay that has a conditional. Uh, hmm, I don't really like that. Let's just not do that for now. Let's say raise not implemented error. Okay, so to do Alice figure out how to um, uh, okay, not implemented error, no support for calling specific operations within system context slash calling or slash different deployment environments yet via system context uh, deployment helpers. Okay, so figure out how we should maybe add conditional on target operation via overlay. We'll spell check. All right, a little auto formatting. Let's check out our stack trace. We got that in a comment. How is this going? I think, oh, this is the file that we've been in. Okay, how is it going? Let's find out. Okay, so if deployment environment is the load default deployment environment, then we're going to go through self.upstream.flow. We are going to we want to do iter tools list set iter tools chain. Where was that? That was in let's do read dfml df or read dfml df types class data flow. All right. Okay. Where's our serialization code? Okay. Autoflow from dict export. Okay. Forward flow, flow. Okay. Where's flow? Input flow. Okay. Flow. Okay. So where's by origin? Update by origin. Okay, so instance name, self-flow items, by origin, set operation dot stage. Okay, so so by origin, so within the stages, okay, so we say Yeah, maybe we can check the by origin. I think this does what we want. I think there's a structure which already does this. So output source in input flow dot conditions, input flow and inputs dot items. Okay, so output name. Okay, so basically, yeah, so basically, I don't know, this is pretty internal facing. What are we doing? 311. Okay. Okay. So what is it doing here? Let's just look at what it's doing. So get alternate definitions, origin. Output source, items, input flow, conditions, output source. Let's grab this. This looks like good stuff. Okay, let's check it out here. All right, so pasted it from 163 through 222. And let's see. So input definitions, so flow. Okay, output source stir, output source items, alternate definitions, origin. So if it matches the origin, so we want to be looking for, what do we want to look for on a default flow? We want to look for any operations that are going to take inputs from the origin, which we understand that we are providing from. So where's origin? Let's set HL search, right? So set HL search. So, and then let's look for origin. Okay. So here's where we're going to find. So by origin, operation stage, output source, stir. So output source is also effectively the origin. Set default origin, like append operation. So these are alternates. Okay. So operation. So if operation dot instance name equals wait, deployment environment. Okay. Equals deployment environment. Then and origin equals I know I said I wasn't going to do this, and now here I am doing it. 311, 314, fuck. Okay. And origin equals, okay, alternate. So and origin equals, alternate origin equals origin, then operation instance name equals deployment environment, and alternate origin equals origin. So if operation dot instance name equals deployment environment, if deployment environment equals load default deployment environment. Okay. So here's the specific, here's the default. Okay. So then in that case, we would say instance input flow, output flow, source conditions. So these are the conditions. So these are conditions which must be satisfied for our origin. as well as if output source equals origin, and then we'll change this origin to alternate origin. Okay. Source equals origin. Okay, origin. Let's do this. Origin. Okay, alternate origin. Output source is the origin. Otherwise, okay. So yeah, okay. So output source, alternate definition. Okay, output source, input flow, alternate origin. Then we need to check the alternate origin over here and the deployment environment as well. Okay. Output source, alternate origin. Okay, it's getting checked there. Output source becomes the alternate origin there. Output source is checked for origin here. Okay, so now we got to fill in these if blocks. And what do we have? Well, we're trying to create this input definitions. Okay, so let's put this up here. We don't know about stage right now, huh? Or maybe we should just do, yeah, maybe if we just went through upstream by origin, all the stages, right? So dot values, and then we said dot output source. So this is our origin, right? Then we should have all of our operations that we care about for that origin, right? So if deployment environment is load default, else so input definitions equals right. So if the instance name, okay, instance name should be unique, so we should be able to do dot inputs here. So, and then here we should be able to say, so we didn't need all this. So Okay. This should be back one level. Input definitions. So this data flow, which can also be found in a more convenient form for this task. Restructured by stage and origin within data flow dot by origin. So originally I screwed up when we were first, this is why it took me a while, and then we ended up with, going back and forth on this and changing the variables just a second ago. So basically we're going to go, so this goes across stages. Yeah, so this goes across stages. So if deployment environment equals operation instance name, okay, that inputs, okay, so origin. So input definition would be operation.inputs. Operation.inputs. So we'll do itertools.chain. Okay, input definitions would be dot items. Yeah, so the trouble with this is that it's going to, so to do raise on duplicate keys. Okay, okay, so input definitions list. Okay. All right, so how can we do this? Right, so raise on duplicate keys. So we can say if len input definitions not equal len input definitions list, we know that something got screwed up when we transitioned from list to a dictionary and we deduplicated the keys because there's going to be tuples of raise value or raise value or yeah raise duplicate input names short names. Okay, but we'll say not implemented error. Don't yet have more helpful, or let's just say duplicate short names, so we can just say input definition list. And all right, so we're going to raise on duplicate short names. So it was fuck, okay, 26. Oh. All right, so raised when duplicate default system context execution would cannot be handled gracefully due to duplicate input values with same shared short name within different operations. Okay, so that leaves us with this, which we should have our input definitions as a dictionary now. So then we should be able to go through input definitions and do key value mapping of the definitions. Yep, okay, so this looks good to me. Let's try to, doesn't look good to the interpreter. 162 was it? 160. See what changes we made. Duplicate short names. All right, let's see how this goes. We haven't fixed that. Okay, so let's just commit this real quick. Where are we? Oh, okay. Did we get all that stuff? I didn't really go to all that stuff. This is what we want to put over in the other file. Wait a minute, why is... I must have forgot to do this. So base move subclass to be this method on base diff object context. Get diff